So due to latitudinal effect, then the value of acceleration due to gravity is decreased. So we have already seen that, and if that is the case, if we are interested in finding acceleration due to gravity at this point P, just making an angle phi with the equatorial line or equatorial plane, then what will be the apparent value of acceleration due to gravity at that point, and what will be the apparent weight of the body. So that is mg dash mg at phi equals to mg at pole minus mr omega square cos square phi. So that this we have already seen, and let us see a problem about using this formula. And what is the present angular velocity of the earth? So this is just to know, omega is equals to 2 pi by t. So 2 pi, what is the time period we have to take? That is 24 into 60 square. So 24 hours. For one day we are taking 24 hour into 60 minutes into 60 seconds. So this is the present angular velocity of the earth. So it is good to know this. Yes. So let us see the first problem. For what angular velocity of earth the weight of the person standing at equator will become 0? So equator means this is the point. So what will be the angle? If this is the line which we are measuring the angle, then this is, the equator is the same this line, so it will be 0. Okay, so W equivalent, that is apparent weight, equals to mg minus mr omega square cos square theta. So what is cos square 0? It is 1 only, so mr omega square. So they have given the apparent weight becomes 0, so the equivalent, that is 0 here. So mg minus mr omega square. So from this mg equals to mr omega square, m and m goes, so omega equals to under root g by r. So what is the value of g? That is 10. What is the radius of the earth? That is 6400 kilometer apparently into 10 cube meter. So 6400 into 10 cube meter. So that is equals to under root 1 by 64 into 10 power 4 radians per second. So this is the angular velocity of the earth. So that if the if in order to satisfy the question, that is the person at equator will feel 0 weight. So let us see another question. For what value of angular velocity of the earth weight of the person is reduced by 60 percentage if he is standing at 60 degree latitude? So this is the question, and please see carefully. It is said that the weight of the person is reduced by 60 percentage, meaning if it was 100 percentage at the poles, then it will be reduced by 60%, meaning it will have only the 40%. Okay, if it is given like the weight of the person is reduced to 60 percentage, then you have to take the final weight is 60 by 100 of that, something only, that is 60 percentage only we have to take. But here they have given the weight of the person is reduced by 60 percentage, meaning that 60% has been lost, so only 40% we have to take. So what is the apparent weight? Equals to mg minus mr omega square cos square theta, that we know. So here we are taking it as 40 percentage because it is reduced by 60 percentage, meaning 60 percentage has been gone and only 40% of the weight is experienced. So 40 by 100 of mg equals to mg minus mr omega square cos square 60. What is the angle we have to take? Angle made with the horizontal line, so this equatorial line, so that is 60 degree, that is given in the question. So 2 by 5 mg equals to mg minus mr omega square by 4, because cos square 60 is 1 by 4, 1 by 2 into 1 by 2. So 2 by 5 mg minus mg equals to minus mr omega square by 4. So minus 3 by 5 g equals to r omega minus r omega square by 4, minus and minus goes. So omega square is equals to 12g by 5r. So omega equals to under root 12g by 5r. So this is the weight of that person when he is at 60 degree latitude. Gravitational force experienced by a particle of mass m placed on the axis of a circular ring of radius capital R. So we are keeping a mass small m here, which is at the distance of the distance from the ring. Okay, so this ring has been like in this direction it is facing. Okay, Now what will be the force experienced? So that is equals to, we have just given the simplest formula, gmmx by r square plus x square whole power 3 by 2. What is capital mass? That is the ring one. And what is the small mass? That is the object which we have considered. And the distance x is this distance from the center of the ring to the mass m, and r is the radius of the ring. So this is what is the force. The value of F is maximum at x is equals to r by 2. The value of F is maximum at x equals to r by 2. So this also we have just given the conclusion. So when the value of x, that is the distance from the center of the ring to the mass small m, is r by root 2, then the value of force is maximum. Okay. And if we are considering drawing a graph, then if the mass is kept at the center of the ring, okay, if suppose this is the ring, okay, this is the ring, and if we are keeping it at the center, then the force will be 0. That is, if please see this one, this axis is for force, so this is 0. As the distance is keeping on increasing on the either side, and when it is reaching x is equals to r by 2, r by root 2, at that point force is becoming maximum. And again, or further increasing the distance, it is getting reduced, and it is same on the both the sides. Okay, for both the sides it is similar case only. So this is the graph. And it is good to know one more thing: if x is very less than r, that is this distance x is very less than r, then we can omit x is in this formula. Then it will be gmmx by r square whole power 3 by 2. So this 2 and this 2 goes, so it is minus gmmx by r cube. So one more thing, so this we will learn again in while we are studying oscillations. But before, okay, let me give a short explanation for this. So F equals to minus gmm by r cube into x. So the general equation for acceleration which we will be studying in oscillation, that is a equals to minus omega square x. So if we are comparing this equation and this equation, okay, from this you can write force is equals to mass into acceleration. Okay, this small m into acceleration, and from this m and this mass, so this m small m will be going. So acceleration is equals to minus g capital M x by r cube. So now I am comparing these two equations. So on comparing, I can write omega square is equals to gm by r cube. Okay, so from this omega equals to under root gm by r cube. This is nothing but finding angular velocity. So this we will learn again in oscillations. If the particle is at the center of the ring, and if it is displaced by a small distance, the restoring force acts on the particle and the particle executes SHM. So yes, if the particle is kept at the center of the ring, then it will execute SHM, that is simple harmonic motion.